Hi guys, how are you doing? So today I'm going to be talking about speed time graphs, right? Speed time graphs. So let's start. Speed time graphs. Okay, fine. When we're saying speed time graphs, I'm talking about speed is the same as velocity. So if you hear the word velocity time graph or speed time graph, it's one and the same thing, right? Because velocity is almost the same thing as speed. Okay, or speed, velocity time graphs, right? So we have our graph like this one, and then it's saying something like that, like that. Do you see that, right? And then we have, let's say 10, 5, 12, and 15 here, right? So we actually have something like this, and then they ask you to find acceleration in the first 5 seconds. We want to find acceleration in the first 5 seconds, right? Okay, this is the part where they are saying to find acceleration in the first 5 seconds, right? So acceleration is change in speed over change in time. So we're going to say change in speed is -10. Since you are coming from the positives going to the negative of the y-axis, it's a negative, and here it's -5. You are also going to the negatives of the x-axis. So it's going to say a is equals to 2 meters per second per second. That is our acceleration in the first 5 seconds, right? Right. Also, they would actually ask us also to find deceleration in the last 7 seconds. We want to find the deceleration in the last 7 seconds. This one here, right? Deceleration is equal to negative acceleration, right? So we'll find the acceleration here. Acceleration is change in speed over change in time, that is -10. Change in time is now we're coming from this one, this side, 12 up to 15. So it's a positive, so it's gonna be over 7. So a is equals to -1 and 3 over 7, something like that, right? Alright, fine. If we have something like this, we say the deceleration is equals to negative acceleration, so deceleration is equals to -1 and 3 over 7. Deceleration is equals negative, we get a positive, so we're going to get deceleration here as 1 and 3 over 7, just like that, right? Okay, fine. Let me have these ones. They will also ask us to find the total distance traveled, right? Total distance traveled is the distance that this motion is covered from 0 to 15 minutes, right? And the distance all the time is equals to area under the curve. It's all the time, distance is area under the curve. So our curve is it's a trapezium, right? So area of a trapezium, we say half a plus b times height. A and b are parallel sides, so it's gonna be half 15 plus, what's the difference here? That's 7, height is 10. So we can literally say half of, if we add those things there, we get 22 times 10. After 22 it's 11. 11 times 10 is 110. So the total distance that was traveled here was 110 meters, right? And they may even ask you to find the average speed for the whole journey. Find the average speed for the whole journey. Average speed, right? Average speed is equals to total distance over total time. this is basically how you answer for average speed, right? So average speed is equal to total distance, we got it here, it's 110 meters over. Total time is 15 seconds. So it's going to become this one into this one. Let's say maybe let's reduce this one here by 5 into here. 5 into 11 is 25 over 5 into 15, it's 3, right? So it's easy now. 3 into 21, it's 7. 3 into 24, it's 8. No. 3 into 24, it's 8. The remainder of 1/3 meters per second. That's how you find the average speed, right? So I said we have a diagram like this. This part here we call it acceleration, right? This part here we call it deceleration. This part we call it constant speed. So if you want to find the acceleration here, you say change in speed over change in time. If you want to find the deceleration here, you also say change in speed over change in time. If you want to find the total distance traveled, you say what's the area for the whole thing then. And then this one here was this one here is a trapezium, right? So I said half a plus beta time. And then the average speed for it is total distance over total time. So that's it, right? Okay, fine. I'll make another video to extend these things. Okay, that's it for the meantime, guys. Cheers.